Let us start day two. So day two is even special. So we have an introductory session with none other than Chris White. Okay, so he's one of the best supply chain expert globally known. I personally like the way Chris analyzed the supply chain things and he presented. Okay, and very knowledgeable and very innovative solutions we are coming across from Chris. So let us do a quick introduction. So the topic of today is digital twins for scenario planning to enhance resilience in supply chain by Chris White. So I think nobody can speak better than you, Chris, for today.
Well, thank you, Abdul, and glad to be here another time. I was part of the second virtual edition back in August and talked about stress testing supply chains using digital twins, and now I want to go a little further than that and
So
talk about how we can use
let me
digital
do
twins to
yeah.
do what if scenarios to increase resilience. And I've been doing this kind of work with digital twins for probably a little over 25 years now. So it's been quite a while.
Hear that. Let me give a quick introduction. Chris White, with over 25 years of experience in Lean Six Sigma, supply chain, program management, project management, strategy planning, he has made a financial impact of over 10 billion for his clients. Previously, Chris held management roles in Raytheon and Alcatel, focusing on total quality management and process improvements. He teaches, he preaches, he builds innovative solutions and also educate people across the globe. So welcome Chris White to the day two of the event. You are the opening speaker. So please welcome to the onboard and enjoy. So we will just enjoy the session today morning. So thank you, Chris.
Well, fantastic. Well, thank you again, Abdul. I'll go ahead and share, and let's make sure that this is, everyone's seeing everything and we're all good. So let me get this into presentation mode and let's make sure that everything still looks okay.
Okay. Screen looks a little smaller. Maybe the window.
Okay.
What you
I think it'll make an adjustment in a minute here. That's what it did last time. Is it still a small screen?
Yeah, let's wait. Maybe it will adjust.
So, Kuldeep, is this what it looked like before, or do I need to change this?
You may try sharing it again because right now it is showing half the screen.
Yeah, that's what we had the problem with before, and I think I
probably you switched between screens, I guess. Are you using? Yeah, now it is back into the file mode. Now just hit on.
So, so hang on. So we'll try sharing again. And this is what I did last time. If this doesn't work this time, so can you see my slides right now?
Yes.
Okay. So let me try sharing and see if it fills the whole screen and looks better. Let's give it a second here. And how does that look? Can't see my screen.
It just looks the same. Yeah, it just half the screen. Yeah.
Half the screen. Okay, so let's do this. So can you see the full slide now?
Yes. Yeah.
Okay. Are y'all okay if I just kind of make that as big as I can?
Yeah.
We can do that. Yeah.
Okay. Does that work?
Yeah.
It's good.
Yeah. I apologize for that. I use two screens and it sometimes has trouble with the two screens. So, well, let's go ahead and let's jump into it. And like I said, I presented at the second virtual edition back in August, and I talked about stress testing supply chains using digital twins. I'm very big on digital twins and have been doing this for 25 years now, representing supply chains with various models and simulations, very, very complex, large supply chains. Lots of fun for me. I enjoy it. And now what I want to do is go a little further and talk about how we can use these digital twins for what if scenario planning to help increase the resilience of our supply chains. And so thank you for this opportunity to come and talk. And what I'd like to do is start with me. And what I mean by me is us. It's our company. Let's pretend this is our company right here. And so we'll just say me. But this is our company, and this is a typical view of supply chain. We're going to build this up over a couple of slides here. And I've got my company. Let's say I'm an OEM, original equipment manufacturer, and I build stuff. I have distribution centers that I send my finished goods to, and they go out to customers. And so we sort of look like this on the outbound side of the house. Now, of course, we have suppliers. We have our tier one suppliers that supply to us, and maybe we have a central warehouse. Maybe our suppliers can actually deliver straight to a distribution center or even straight to a customer. So this is a typical view of a supply chain. The way we typically nowadays look at when we say supply chain and end to end, we say we're talking with our suppliers and we're getting things to our customer and we're tracking that. But this is not the full supply chain. This is the full supply chain. When we have suppliers that supply to our suppliers who supply to us. And so if we order something from our supplier, the only way we get that is if their supplier gave them enough and their supplier gave them enough, and so on and so on. And so it is much deeper to really get the full end to end supply chain. And the reason we want to do that is if we want to talk about resilience, which is something that's a big topic right now, ever since the pandemic, we've had the bullwhip effect, we've had all these disruptions, you name it, the Red Sea, Suez Canal, Panama Canal, all sorts of things happening, bad weather in different areas of the globe, political turmoil, things like that cause lots of problems. And so we talk about having resilient supply chains that can adapt, react, recover from things that happen. But what's interesting is that when we talk resilience is really a system phenomenon. It's not an individual company. Now, an individual company can be somewhat resilient, but it's sort of individual resilience and it's very limited. The whole supply chain as a system has to be resilient to really be able to address and react and recover from some of these situations that we're talking about. And so the only way to understand and assess this resilience, to look at it, is to treat the supply chain as a system. It's a lot of companies that are interconnected and work together, almost like a sports team, where they each have their roles and they do everything, and they're all needed to succeed, and they all have to work together to succeed. But we want to conduct what if scenarios using this system view of the supply chain to see how the supply chain overall as a system acts, reacts, responds, recovers from various changes that may happen. And when I say various changes, we're not really talking about small changes. A couple, 2% demand increase. Not that's easy for everyone. Companies can handle that now with all their software. What we're looking at are big, major changes. Swings in demand up to 20, 25%, 50%, decreases that are of the same order, disruptions, transit channels or transportation channels getting shut down, things like that. That's what we want to now look at. And to do that, we've got to kind of take a bigger picture view and look at the whole system. So we also mentioned, like I said, resiliency. So I want to talk about 4 common methods for increasing resiliency in supply chains. Now there's a lot of methods, but these are 4 of the most common that we might see, and we're going to pick on a couple of these as we do our what if scenarios. So the first one is that I can add suppliers for my critical parts or components. So this is me. I have some tier 1 suppliers, and at tier 2, I'm going to have not just 1, but 2 suppliers for a critical component or system. And that way I can shift orders as needed. So that's one way to increase the resilience of our supply chain. Another way is to regionalize suppliers. And what I mean by that is to bring suppliers closer to me. And again, we're pretending here like we're an OEM, original equipment manufacturer. So I'm trying to bring my suppliers closer to me. In the United States, we call that nearshoring or onshoring, because typically we have some suppliers over in China or some Asian countries, and we may uh, have issues with that, political issues, and we now have a new elected president that will have different views than our current president. So all these things come into play, and so we have this process of, or this idea of regionalizing or bringing suppliers geographically closer to us to make it easier to deal with them. Another option is we can add inventory at various places in the supply chain. And here I'm using a black circle to represent a lot of inventory or a little inventory. And in this example, I, as the OEM, am holding some extra inventory, and I have one of my tier one suppliers holding some extra inventory. But this is just notional. We could have a full supply chain and have this extra inventory anywhere. And that inventory, the purpose that it serves is to be a buffer for when demand is higher than what we want or lower, and we can use that inventory to help us make adjustments and have some extra to account for these. And then another very common option is just to increase our priority in the eyes of our suppliers. I may pay extra, I may order more. I'm trying to put myself in a position so when my supplier has a choice of sending materials to me or my competitor or some other company, they choose me because I'm their biggest customer, their biggest client, or I'm paying an extra premium fee, something like that. I become a higher priority to my supplier. So these are four very common ways that we try to increase resilience. And I want to walk through a simple what if scenario first. And we're going to look at that first option of, should we have two suppliers? What does it mean to have two suppliers, and how does it help with the resilience of our supply chain? So I'm going to build up a model that we're going to see throughout. I'm going to walk through two what if scenario examples. This is our first one. There'll be another one, and we're using the same model so that it's easy for us to kind of say the same things. We see some of the same graphs. We see some of the same numbers. And in this baseline model, what we're using, the flow, the demand will be 100 orders a week. That's nice and easy. That's a good, easy number, 100 orders a week. Our simulation, if we want to look at the supply chain as a system, then we're generally talking longer periods of time. So several months to even a year, multiple years. And some of the work we did for the military, the U.S. military, was actually decades. So these supply chains take time for things to ripple through them. And so we want to make sure we capture some of that. So we're going for the simulation is for 2 years. And what we're trying to do is hold 4 weeks. Our kind of target inventory is 4 weeks of inventory for raw material and 4 weeks for finished goods. So if we start to look at what the model kind of basically looks like, we've got this. I've got deliveries that I'm making from an inventory of finished goods. That finished goods gets, I have a production process. We have a production process that creates and produces and manufactures products that go into that finished goods inventory. And I have a pile of raw material inventory that I'm using to produce with. And then, of course, I'm receiving my raw materials from my tier one suppliers. And if we take a look and we do some of the math, if we have 100 orders a week going through, I'm delivering 100, and really I kind of have this flow of 100 going all the way through. I'm receiving 100, producing 100, delivering 100. Every single week I'm doing that. And I'm trying to hold 4 weeks of inventory in raw materials and finished goods. And so I'm showing that with the 400 here. So this is the model that we're going to use throughout the other simulations. And so this is kind of our baseline model, and what every entity in the supply chain, the scenarios that we run that are going to be done with the structural simulation. This is what that model in a big picture kind of looks like. So I want you to also know that every slide you see, all the results that you see, are only results for the OEM. Me, this is the company I care about. I'm the OEM. And so we could easily show results for all other companies, but this is just going to be the OEM. So we're always looking at graphs for the same company, the same player in the supply chain. In every model, everyone's operating the same, just like this is showing. So in this case, in our baseline scenario, we have an OEM, that's us, in the upper right here on the slide, and I've shrunk that picture so you see what's happening there. And then we have our tier one supplier, supplier one, we're calling them, and they have that same model also. So everyone's always trying to hold 400 in raw material and finished goods, and 100 is always flowing through because the OEM, our end customer, wants 100 a week. So in our baseline scenario, remember, we're understanding the resilience of having two suppliers. So we're going to start with just this baseline scenario. I have an OEM that's us that has a single tier one supplier that's called supplier one. Now, these are the results of a 2-year simulation. No changes. Everything's great. We're always delivering 100. We're always holding 400 in our raw materials inventory and our finished goods. So a lot of times when we're doing these, when we did the stress testing before, when we presented in the second virtual edition, and right now when we do what if scenarios, you want to start with equilibrium in kind of a steady state flow, and that's this 100. So it's nice and easy. Now, when we make changes and we see these graphs begin to do different things, we know that the results are because of those changes. So it's sort of like a scientific experiment that we're doing here. So I also we're going to build a table here, and we're going to compare all these scenarios in a table. And in this example, by the end of the simulation, we had $120,000 or $120,800. We got 10,400 orders. Remember, this is 2 years, 52 weeks a year, so 104 weeks total. We're getting 100 orders every week, so that's 10,400. We delivered all 10,400, and the minimum profit margin that we see in this baseline steady state equilibrium situation is 20%. So we're always making 20%. We're always delivering 100. We're always holding 400 in inventory. So now let's make it interesting and begin to unfold why we might want a second supplier. And so let's go with scenario one. And in scenario one, our supplier, our single supplier, has a disruption starting in month 6. And that disruption is so bad, it basically takes them offline the rest of the simulation. So nothing happens. The supplier goes offline and we don't see him again, and we have nothing to replace it. So as expected, we're going to start the same we did before, but we're going to drop to 0 with everything over time. The black arrow indicates where the disruption with our supplier occurred. And you'll notice immediately our raw materials begin to drop because we're no longer receiving anything from our supplier. So our 400 begins to drop. And we had 4 weeks in raw materials and finished goods. So we see finished goods last a little bit longer because there's that 4-week delay right there. But eventually that finished goods starts to drop also. So I ran out of raw materials. That eventually means I run out of finished goods, and eventually impacts the deliveries. And when finished goods starts going below 100, then of course we can't deliver more than that. And so we eventually go to 0. So our raw material goes to 0. 4 weeks later, our finished goods and our deliveries go to 0. Not a good situation for us, right? That's horrible. And of course, we're kind of being dramatic here. We had a supplier, they went offline, we couldn't replace them. So of course, if they went out of business, we're going to go out of business. And if we look at the finances now, we not only did not make money, but we lost money. We had 10,400 orders. We only delivered 3,500. And that was really just in the first part of the first 6 months of that simulation. The first, 35 weeks, we had, the disruption occur after 6 months. And then a few weeks after that, we finally run out. And so we were able to deliver 3,500. Our minimum profit margin, the worst it ever gets, is in the toilet. It's horrible, negative infinity, because at some point we're holding lots of inventory inventory and we're not making any sales. So that's a terrible situation. And of course, we're kind of being obvious here. So now we want to consider another situation, scenario 1A. So this is the same as that first scenario, but now as soon as our supplier 1 goes offline, we're going to go set up another supplier. We're going to start from scratch and set up another supplier, and we're going to say that it takes 4 months to do that. Now that's really pretty quick. It generally takes longer, but for the purpose of this simulation and this what if scenario, let's just say that. So in the end, this is what we look like. A supplier 1 goes offline. We stand up supplier 2, and here comes supplier 2. Some time after that. If we look at the graphs, then what we see is that first half of the graph. Now the scale has changed because now I have these oscillations, and so the scale has changed. But we're starting with that same 400 in raw material and finished goods, and we're delivering 100. So that's the left part of this graph, the initial part of this graph. The first black arrow at the top there is representing us, the supplier 1 having a disruption and going out of business and going offline. So we see the same behavior we saw before, where our raw material dips, that's the blue line, and then a few weeks later, our finished goods dip, and then eventually our deliveries dip as well. What's different with this is we start to come out of that hole because we bring a second supplier on after some period of time, after some delay to get them set up. They come online and we build back up. And for a while, we over deliver. We're delivering almost 200 because we have this backlog of orders and we want to make up for that. So we do that for a while and we make up. And then you see at the end, way at the far right, that our deliveries eventually kind of settle down at 100. We're sort of back to that steady state, and the red line for the finished goods is back up to 400. And our raw materials have this little bit of a bullwhip effect, and so there's going to be some overshoot and some undershoot. When we compare this in the table with the other information, we actually we have a little bit of money at the end, not near as much, but we were able to deliver all our orders. Now, we suffered a pretty bad minimum profit margin. That doesn't mean we're staying down there the whole time. It just means with all this dipping, and as we have excess inventory, but we're not making many sales, then suddenly our profit margin can tilt a little bit. And so, we're not as bad as the negative infinity, but we're still pretty bad. So now let's consider the situation of what's the value of having a second supplier already online. So I have 2 suppliers. So same as the other scenarios, I'm going to have one supplier go offline, but I started with 2 suppliers and I have 40% going to supplier 1 and 60% going to supplier 2 when I start. Once supplier 1 goes offline, I move all orders over to my second supplier 2, and now I'm 0 orders from supplier 1 and 100 orders to 100% of orders to supplier 2. And so now we're going to look at that situation, and what we see is something that's a lot better. We see here's the same scale and chart that we saw just that last one. There's the black arrow for the disruption. And we see that raw material dips, but not nearly as much because remember, we already had a supplier that was supplying us, so we don't completely run out. We do dip for a while the second supplier builds up from 60% to 100%. That takes a little while, and so we're not getting everything we need immediately. So we do suffer a little bit of loss, but not near as bad. And if you'll notice, the red line for finished goods barely dips at all, and our deliveries don't change any. Our deliveries never change. So when we come to this chart now, we see that with a second supplier already online, and now we're just shifting orders, we make almost as much money as we did in the first scenario when everything was perfect. We met all the orders, and at one point in time, we only suffered a negative 5% profit margin, and then other times we were making money, but not near as bad. But we did dip one little bit at one point. So what's interesting is when you start comparing all these. So now this is the benefit of doing the digital twins in what if scenarios, is now I can lay all these results together. And this is looking at the raw material in all 4 scenarios. My baseline is straight across. I'm always holding 400 raw material units in raw material. You see scenarios 1A, the black dots, and the red line, scenario 1. Those both go down. Scenario 1 stays down in the tank because nothing is there to replace it. In scenario 1A, that's where we have a second supplier come on. We see that grow and eventually begin to get up and would eventually settle down if we kept going. Then the green dash line is scenario 2, and we see that dip, not near as bad. And then we see it kind of come back and do a little bullwhip oscillation as we typically see. Looking at finished goods, we've got here's the black line for the disruption at our supplier 1, and you'll see that the red line for scenario 1, just like we saw it before, a little bit after the raw material dips down, hits 0, stays at 0. Scenario 1A goes down, does kind of runs out barely for a little bit, but then begins to climb out of that hole and gets us back up to the 400 in finished goods. But then our scenario 2 really only dips just a little because we always had our dip in raw material wasn't as bad. So we always had some raw material there. And then the last thing is, let's look at deliveries. Our baseline straight across. The black arrow, of course, represents that disruption, the time of the disruption. And with scenario 1 and scenario 1A, they dip. Scenario 1 stays down, no more deliveries. We don't have anything. Scenario 1A comes up, over delivers for a while because we have an orders backlog to make up, but then says, I met it. Now I'm back down and I'm back to 100. And you'll see scenario 2 is a straight line, just like the baseline. So never suffered. So this is the financial view of that. You'll notice that they all sort of line up for that first 6 months of the simulation. And the black arrow represents the disruption, of course. And the red line, scenario 1, you see just tanks. From there on, it's just losing money because we're running a company with no raw materials, can't make any sales, and so we just go in the tank. Scenario 1A is not as bad, has trouble for a while, but then if we were to keep this going, we'd see that it sort of levels out a little bit later on, but not near as bad. We actually still have some money, but we've lost money along the way. And now you see scenario 2 and the baseline are roughly the same, kind of up there at the top, kind of a constant growth like that, because with scenario 2 having a second supplier online already, then we were able to maintain that business level. And so what we're learning here is the benefit of having a second supplier already online, not for everything that you do, but at least for some of the critical components or systems, because if you don't have that, then you suffer some significant losses and it takes a long time to recover. You may even lose that business. We're not even considering losing business to a competitor because for a while you can't deliver. So there's that business impact as well. We're just pretending like all our customers are still there, and yet we still have significant impact. So by having a second supplier online, we just use this digital twin to run some what if scenarios to show we can be more resilient to recover when we have this second supplier of some critical system already online. And so that's one example. So we wanted to hit on that. What I'd like to do now is get a little more complicated and do another one where we're looking at disruptions throughout the supply chain. And this now has an impact on the nearshoring or the regionalization of our suppliers, how close they are to us, both in terms of the tier in the supply chain, but also geographically. So we're going to see which disruption at a supplier has the biggest impact on me. Now you notice this is a much more complicated scenario than what we ran before. Here, we're the OEM, as always, and the charts are going to be for us, the OEM. We have a tier 1 supplier like before, but now we're going to go down to tier 2 and show that tier 2 has 3 components. I need all 3 of those components to make up my system at tier 1 that then gets delivered to me as the OEM. And these are arrows showing the deliveries from one, and we've got little images for that same baseline model because I just want you to know everything's the same. So you're going to see some very similar charts, except for it's relative to this particular situation. Now we're going to lay this out geographically. The OEM, us, the OEM, are the black box in the upper left. The yellow box is our tier one supplier who is in the United States in this situation. We have our three component suppliers at tier two. One is in Mexico, one is in Africa, one is in China. And so we're kind of looking at the impact of all of these. And the white numbers are the shipping times from one supplier, one company to another. So from our tier one in the United States, it's on one side of the United States, we're on the other. So it's a week. From our tier two component supplier to the tier one is 4 weeks. From the African supplier, it's 8 weeks, and from the Chinese supplier, it's 12 weeks. So that's kind of laying out the scenario. So we know those models, but we wanted to give a geographic view of that. Now, here are the things that we're going to look at. We're going to start, our baseline is always that normal steady state, 100 orders a week for 2 years. Everybody's fine. We're going to see straight lines. The next 4 scenarios are just taking that same baseline, but shutting down one of the suppliers for 2 months, pretending like they have financial problems or something for 2 months and they can't deliver to us. So the first scenario is our tier one in the US. The second scenario will be our Mexico tier two supplier. Our third scenario will be our Africa tier two supplier. And our fourth scenario will be our China tier two suppliers. Remember, the graphs that we're looking at are always for us, the OEM. So just like before, although the scale is different, same results as we saw in the baseline before. Steady state, we're in equilibrium, we're always delivering 100, and we always have 400 in raw material and finished goods. Let's build another chart. We're going to add a couple of variables to this one because it gets pretty interesting. So you'll notice the numbers are the same as before, 120,800, minimum profit margin of 20%. All our deliveries are on time. It takes a week to deliver them, and we have no recovery times because we're doing fantastic. But we're gonna see what happens in these other scenarios, and we're gonna look at recovery times to 50% of our deliveries, then to 100%. What the highest and lowest raw material spikes were, what the highest and lowest finished good spikes were, what our highest order backlog spike was, because how many are sitting there waiting for us, and are there any changes in the lead time and our on-time deliveries and all that. So scenario one, tier one supplier in the US is offline for two months. And it's the same time, it starts at the same time at 6 months like we did in the previous scenario, and now they're offline for 2 months and coming back. So remember, these results are for the OEM, us. We see similar dynamics where there's, the tier one goes offline, but we actually don't immediately start losing inventory because that tier one actually had some inventory. It quit producing, but it was still sending us a few more weeks of inventory. 4 weeks, we had 4 weeks there. So we buy 4 weeks there, we run out of raw material, we buy 4 weeks, and then we run out of finished goods and run out of deliveries. But since that disruption was only 2 months, it comes back, that tier one supplier comes back online, kind of over delivers for a while. There's this ramp up, again, the kind of bullwhip effect of raw materials, but we settle down and we're back to where we were, except our raw materials are kind of fluctuating a little bit. But let's look at that impact on this chart in comparison with the baseline. So again, still comparing to the 120,000 and the 20% down there, but we don't make as much money. 44,000, again, 2-year simulation, the exact same simulation. And we suffer for a while, and it takes us 13 weeks to get back to just 50% of our deliveries. So 50 takes us 15 weeks to get back to 100% of our deliveries. So we're kind of climbing out there. It takes a long time to get to 13, and then a couple of weeks later, we're there at getting 100%. Our lowest raw material inventory was negative 100%. We ran out. And then we had a 165% spike. You saw that first part of that bullwhip effect. Our lowest finished goods inventory was negative 100%. We ran out of finished goods also. Now, it never spiked above 400, so it's the plus is 0%. We just came back to 400, but we ran out at some point in time. And because we ran out, we had this increase in our orders backlog, 1,280% increase for a while. Our lead time also went from 1 week to the longest lead time at some point was 14 weeks in that simulation, and we only delivered 71% of our total on time. And if you recall, the bulk of that was the first 6 months when we were doing fine, and then at the end when we were doing okay. So we kind of lost almost 30% in the middle there. We do, because we go down to zero raw materials, zero finished goods. Mathematically, again, we're that negative infinity, horrible situation. So now let's sort of go around the groups here. We're going to do that same disruption at the Mexico tier 2, then Africa, then China. So here's what happens if that is with the Mexico tier 2 supplier. The black arrow again represents the disruption when it occurs with that Mexico supplier. But remember, the Mexico supplier has had finished goods that were coming. Our tier 1 also has both raw material and finished goods, so we buy ourselves a lot more time. We still hit this point where we run out of raw material, and remember, there's this 2 months, so we're kind of we survive part of that 2 months, but toward the end of that 2 months, we get down to roughly zero, but immediately start crawling back out. So it's a similar chart to before, but we're not down there as far. And if we do a comparison, we see that we're in much better shape. This means our tier 1 is online. This is the tier 2 Mexico component supplier going off. And you'll notice we get up to 109,000. There's a significant difference in the recovery to the deliveries. We get back to 50% in 4 weeks and 100% in 6 weeks. Our lowest raw material is negative 99%. So we didn't actually run out. We came really, really, really close. If it was a 3-month disruption, maybe we would have run out. But in 2 months, we came really close, but we didn't actually run out. And our spike of raw material as the bullwhip starts is 75%. So not too terribly, not near as bad as the other one. With finished goods, we get down to a negative 97%. So we still have 3% there that we didn't run out. And we don't overshoot either. Our highest, because you can see from the recovery and was a lot faster, obviously isn't going to be as high. So we went up to plus 345%. Our longest lead time was 4.5 weeks instead of 14. And we actually delivered 87% now on time. And at one point in time hit a negative 375% profit margin, but it wasn't the negative infinity going in the tank. So still a little bit better. Now we're going around. Now it's the Africa supplier that's 8 weeks away, and it's going offline. And now let's look at these dynamics look very similar. We have the disruption, but you'll notice that the Africa supplier, when it goes offline, we're not impacted as badly. We do have the dip in raw material, but you can even see on this graph that it doesn't get down to zero. Our finished goods, that red dash line, definitely doesn't get down to zero. And you see the deliveries don't drop to zero either. They just kind of fluctuate for a while, and then they're okay. And our raw material oscillation was smaller. So when we look at this chart, now we're comparing the different what ifs, and we're seeing that there's even, we've done even better. So now financially, we're 120,000, only a 2-week recovery and 3-week recovery to get back to 50 and 100%. Negative 96% on raw material. So we still had 4%, all right. But with our finished goods, it only went down to negative 83%, so 17%. So we still had quite a bit of, a decent amount of inventory to cover us. The orders backlog only went up to 68%, and the longest lead time was just 2 weeks, not near as long as the others. And we were able to deliver 93% on time and a lowest profit margin of only negative 11%. So now let's take a look at the last example, the tier 2 that's over in China and has a 12-week transit time. And now we look similar dynamics, but it's not near as bad. I forgot to put a black arrow for the disruption, but we kind of all know where that is at month, roughly 24, 25 over there. But you'll see the raw material doesn't dip near as much. The finished goods don't dip near as much, and our deliveries actually stay flatlined because our finished goods never dip that much. Our deliveries didn't suffer. And if we now look at this, in this particular case, we actually happen to make slightly more than our baseline. It just works out that way because of some over the raw material dipped at some point, and so we sold the same amount, but had less raw material, and so in the end it looked like we made a little bit more. But we don't suffer any recovery because we made all our deliveries. We do have a little bit of spike in raw material, but we only go down to negative 90%, or we maintain 10%. And we're only about half of our finished goods inventory. We don't have any spike or any growth in our orders backlog because we were able to meet all deliveries, kept our 1 week lead time, 100% of deliveries online, and we suffer a negative 8% profit margin just for just based on how the numbers line up. When we lay these all together, the raw material, it's kind of tough to see, but you can see that red dash scenario 1 drops. That's our tier 1 supplier. And you'll notice the next 3 kind of line up. It's Mexico, Africa, and China. So there's a big difference between our tier 1 and our tier 2s, but even among the tier 2s, we're seeing slight differences. And what it ends up coming from is that the longer transit times, it's 4 weeks from Mexico to our tier 1, it's 8 weeks from Africa, 12 weeks from China. That's 4 weeks longer each time. And we can see that right here, that inventory was actually being held in that transit time, in that, all that whole pipeline inventory, which actually protected us against this disruption a little bit when it was further away. So China was the best. And so you kind of see those lay out as well. And that allows us to even just prioritize and say, hey, depending on which supplier there's a disruption, we can tell you which one hurts us the worst. Our tier 1 hurts us the worst. And then it's sort of geographically with all our tier 2s. And if we look at the finished goods, we see, again, this is laying all the results that we saw. Scenario 1, we tank, we come back up. And then the other 3, you'll see all kind of work in unison with about a 4-week gap between them. Then the Mexico supplier, scenario 2, dips down. Scenario 3, the Africa supplier, not quite as far. And scenario 4, not too bad, only about half. And when we look at deliveries, we see again, baseline is straight across. Scenario 1 dips, over delivers for a while. Scenario 2, when the Mexico supplier is disrupted, dips, doesn't run out, overshoots for a while, comes back. Scenario 3 is even smaller. That's our African supplier. And then scenario 4 is a straight line. Deliveries are never impacted. So what's interesting here, we'll just kind of summarize some of this in some conclusion and observations that take us back to resilience and what the things that we need to worry about, and how we can use these digital twins to show us what are ways that we can increase resilience, what are ways that we can analyze that supply chain as a system and understand. The first thing is relying on a single supplier can be disastrous. What we just saw in that first what if scenario, and we can reduce our risk and increase our resilience with additional suppliers. Now, again, you don't want additional suppliers. You don't need additional suppliers for everything, especially things that might be commodities and easy to get from other suppliers very quickly. But some of the critical systems that are time sensitive, take a lot of time to build. Those are ones you may want to consider having second suppliers already in place, just so that it's easier to shift and you are more resilient when that happens. I mentioned that this is in the previous stress testing presentation. We talked about structural simulations versus statistical simulations, and this is a structural simulation, and it means you can actually look at the supply chains and get some understanding of the risk and resilience with little or no actual data. So you'll notice we just did 100 orders a week, 4 weeks of inventory, and then we just looked at everything relative to that. So it's a really interesting way of getting some answers and sort of exploring possible solutions early before they arise, before you really have data about them. You can begin to understand how they impact your supply chain. And as more data are collected, of course, we add that to the model and it gets better and better. Another thing we learned is each supplier has a different operational impact on the supply chain, and especially us. Usually we care about ourselves and us. So that same disruption, again, using a digital twin, you can do this scientific experiment. Everything stays the same, except we're going to change one variable, and that is the location of the disruption. But with the same disruption in different places, different suppliers can have different results based on that. And the resilience of that supply chain can change based on the locations of suppliers. And I put locations in quotation marks because we saw the tier one versus tier two. That is a location in the supply chain. It's the tier location, the hierarchical location. And then also geographically, we showed that the further they are away, the transit pipeline actually has extra inventory that can be a buffer for us. But it allows us to prioritize um, where perhaps we want to go dig for data and go get some extra information, because it usually costs money and time to go get more data and understand things. So this can now help us understand. And in this particular situation, we'd obviously want to go get lots of information or as much data as we can about our tier one, because if they go out, that's our worst situation. And last, no company in a supply chain is an island. It's a system, and we need to look at it as a system when we're talking about resiliency and see how the decisions and actions of each company in that supply chain can actually impact others. And this is kind of a summary of what I was just saying about the location. That the closer, and there have been several academic papers on this, the closer the disruption is in your supply chain structure, that is your tier, the greater the impact, because you don't have all these inventory buffers. So when our tier one is worse, then tier two, and then tier three. So if we had a tier seven and there was a disruption at tier seven, we may not even have to worry about that at all, because each tier in between is a buffer and has a chance to act and react and recover. And by the time that ripples to us, it could be very, very minimal. But this also applies geographically. The closer the disruption is geographically, the greater the impact due, again, to inventory buffers. And if it's a long supply chain, a long transit, you've got extra inventory in that in transit that can be a buffer for you. So the challenge ends up being balancing efficiency and resilience. Those two cannot exist. You can't be highly efficient and highly resilient at the same time. Efficiency requires cost optimization and doing very specific things in a very specific set of conditions. Resilience, on the other hand, is being adaptable, being able to change and recover when all these different things start to happen. And generally that requires extra inventory, extra suppliers, some of the things we talked about, which costs money. So it's not cost optimal where we're trying to be efficient is. So those are opposite ends of the spectrum, and we've got to be able to consider them both. And what I like to use for this, the analogy is a tree. A tree has a trunk and it grows, and you get major branches, then minor branches, and then twigs with leaves on them. And so it's almost like going from abstract to detail. So kind of the big picture down to this very detailed picture. And we like to say, as we're talking about digital twins and what if scenarios and resilience, what good is optimizing the leaves here when you should have been taking this other branch to begin with? And so if strategically what you're trying to do with these digital twins and what if scenarios that are these long-term strategic views, you're trying to understand strategically what's the best direction to go. And then now we can optimize. So let's get in the right direction strategically and then make our optimizations based on that. And so I want to kind of close with that I want to put that to your consideration, that as you're in your companies to understand where your company is on that spectrum between highly efficient and highly resilient. You don't want to be either end of those, because highly resilient costs a lot of money, but you don't want to be super efficient either and super optimized, because that makes you brittle and fragile and you can't make your adjustments. It means you can only work in this one situation. So you want to be somewhere in between on that spectrum. And so I'll just kind of end with that note as we talk about using digital twins and what if scenarios to increase resilience. And hopefully you've seen a way of doing that. And I will open it to questions now.
So great. Thank you. Thank you, Chris. It's a wonderful session once again. So it's really insightful. Okay. So there are many things always when you brief, so it becomes more clear. Okay, there are a few questions we have posted. We got from the YouTube and others. So
Okay.
the question number one is, uh, it's a great concept. How the digital twin concept can be applied to pharma supply chain? That is a question
To
number one.
pharma, well, it can be applied to any supply chain. I will say this: the more complex the supply chain, the better or the more important it is to do these kinds of analyses, these kinds of what if scenarios. So if you have a very straightforward, 3 entities in my full supply chain, that's not that complicated. You can probably figure everything out without much effort. But if you make something very complex, the supply chain typically mirrors that. So when you're talking about pharma products or electronics or appliances or airplanes or cars, those are very complex. And the supply chain will generally look like that bill of material, that breakout. So if you have a thing that's made up of other things and other things, there will most likely be suppliers that look just like that. And so that is generally a starting point. And so pharma with very complex products with very high technical content is a great example for using something like this.
Mhm. Yeah. So the same person has asked for what is the data readiness and systems readiness required to design a digital twin, and how long it will take.
Can you ask that question again? It cut out for just a second.
So what is the data readiness and systems readiness required to design and build data twins?
Well, so
Sorry.
what's
Yeah.
interesting, if you use a structural approach like we use with SCM blocks, is it doesn't take much time at all, in all honesty, and it doesn't take much data at all. The difference, and you may want to go back and see that second virtual session where we talked about stress testing and we talked about structural modeling versus statistical modeling. And with structural modeling, what you're looking at are the interconnections, the relationships, and the connections among all the entities in that supply chain. And that tends to drive the performance and the behavior of that supply chain, uh, the more complex it gets. And so you actually don't need data. I don't need to know exactly how much inventory is being held at this one company or exactly what the orders are. You saw in our examples, we just picked 100. That could have been 200. It could have been 173. What we're looking at is the relative differences. So when you saw those raw material and finished goods rise and dip and the deliveries drop, what matters is more the relative difference, not so much the numbers. And so we want to see, well, you know, do we go to twice? Do we end up with twice the inventory or 3 times the inventory? And again, whether it was 100 or 1,000, it just means it goes up to 300 or 3,000, and it ends up being relative. And what you're looking for are more like tipping points in behavior of when do things suddenly crash for us, or when do things accidentally take off for us. And so you can do a lot of that without data. I encourage you to look up structural models and see what you learn there.
Perfect. Perfect. So the third question is, because how does artificial intelligence help to build digital supply chains? Okay. So
So what's
because of
interesting,
this, yeah. So it's a
what,
new, new wave of innovations through AI.
yeah.
Does that
So
AI affect digital twin development?
what's interesting here is this is sort of the original AI.
Mhm.
Decades ago, AI meant I'm going to have an autonomous agent and I'm going to see how it acts and reacts. It's exactly what we're doing with these simulations is we showed an OEM and a tier one. They are autonomous agents that are reacting and reacting based on policies that we set in the model, but you can change those. But based on those policies, they're acting and reacting a certain way. They're closing their gap in inventory either quickly or slowly. they're delivering, they're keeping the orders backlog and then delivering based on that and over delivering for a while to work off the backlog. And maybe they want to do that quickly, maybe not. So that's the original AI from decades ago. Now AI tends to be more statistical and it's more looking at how can we optimize certain things. But the AI that this is using is now what they call agentic AI, of how you use AI as agents. And that's exactly what this what you saw with SCM blocks, at least, are digital twins using agent models that behave and react based on policies.
Perfect, sir. Perfect, perfect. That's great. So, the question for me is, how can we integrate other supply chain planning and supply chain execution systems or ERP to the digital twin? So, how does that integration take place? How does that data is useful to represent the digital twin? Okay, for
Yeah.
the entire supply. Yep, that's the
So
question.
I did say with the kind of digital twins we use at structural modeling, you don't need data to build the model, but you do want data to begin to calibrate that model and get meaningful results that tell you closer and closer exactly to what you want to do. And so when you talk about combining with tools like Frui SCE or ERP systems, it's really an add-on. They're both Frui SCE is looking at some of that short-term, what is happening with my tier one and trying to manage that system day to day. What we're doing are strategic long-term simulations. You don't do those all the time, but you do want to grab the data that Frui SCE or an ERP system might have and say, now let's project forward. And so where a lot of the tools today, like Frui SCE and ERP systems, are constantly running and constantly evaluating and trying to show you today, tomorrow, next week what's going to happen. What we do with these digital twins is say periodically go look long term. Every couple of weeks or every month, do this big what if scenario analysis that starts to look at things that are longer term, and then let those feed back to say, well, then this is what we ought to change in the short term to get to those long-term results. So they pair nicely, they pair perfectly.
Perfect, perfect. So one more, I think the last question is, where can we get more information on digital twins for supply chain? Any reference or so written by you or any other author? Yeah. So what do
Well,
you,
you
what is
could.
your? Hmm.
Okay, if you look up structural models, you and if you go to SCM blocks, SCMBLOX, scmblocks.com, we do have information and we have white papers and things like that. And there's also, if you look up SCM blocks on YouTube, we've got a channel. And in fact, the structural versus statistical models, I have that uh, posted, so you can just learn that one bit. It doesn't talk about the tools, it just talks about these two different approaches. And so on that channel, in fact, you'll see some of the slides that I just showed. We did webinars, and there are some connections to some of those as well.
Perfect. I think that those are the questions we had. So any final thoughts, Chris? So thank you for staying so long. It's at
You,
12 o'clock midnight at your
it
your
is.
place.
It is midnight. It is, and hopefully I still look awake. My eyes aren't starting to close. Um, what I want to say is it's a very exciting time right now to be in the supply chain world. Things are changing so much, and so much innovation is coming into this field. You mentioned AI. There was the question about AI, and the learning, the LLMs, the language learning models are all playing such a big role. What we have to do, though, as practitioners, is understand, just like a hammer is different from a screwdriver, there are different tools for different jobs to accomplish different things. We need to understand the technology, the tool, and where that applies best. And some of the optimization and statistical AI and LLM type models apply very well to the short term of what happens now, what happens tomorrow, what happens next week or in a few weeks. But the structural modeling and some of the agentic AI then applies more to these longer term. And so you want to know both of those and use them accordingly. You don't want to use optimization models to try to model 5 years into the future, but you don't want to take digital twins that are structural models because they're not built to find out tomorrow what happens. So each tool has its purpose, and it's very exciting to just see all this starting to come together in the supply chain world. So those are my final thoughts. It's an exciting time.
Yeah. So exciting time for supply chain professionals, guys. No matter what technology comes, all the technology come and solve supply chain problems, but supply chain operations are not going to go anywhere. They
Yeah,
are going to
exactly.
stay. You have to run. You have to have your food on table. You need to have a car to drive. So all these things can happen only with the proper supply chain. So supply
Well,
chain is the way forward. Okay.
yeah, and
So
Abdul, I'll add. You mentioned driving a car, and the analogy that I like to use is when we drive a car, there are some tools, supply chain tools, that are great at looking at the next 10 feet or 20 feet in front of you, or 10 meters or 20 meters in front of you. But eventually you have to look and see where's the road going a mile ahead. And that's the difference here. You got some tools that are great at understanding what to do in the next, 10 to 20 meters. And you've got some tools that you have to use periodically to say what's going to happen in the next mile. And you need both of those. I mean, as drivers, just think as when you're driving, you look down to see what the car in front of you are doing, then you look up to see what traffic ahead or what's ahead. And we just have to do the same thing with supply chains as well.
So fantastic. With that note, so thank you, Chris, on behalf of participants, the organizer, and it's really a very interesting topic and very complicated topic.
It
And
is.
it is heard from you. That is the best thing we can do. Okay, so thank you. And
You bet. Well,
yeah,
thank
thank
y'all and
you.
have a good, I'm going to go to sleep, and y'all have a good rest
I
of the
think
conference there.
take care and then let us catch up sometimes. Okay, so have a
Yes,
good time, sir.
definitely.
Thank you.